This video is about Splunk ITSI. So before we start, first of all, I would like to inform you that Splunk ITSI is a premium solution of Splunk. So you need to purchase extra license for that for ITSI, and you need to contact with Splunk PS for that, Splunk support. So let's begin. What exactly ITSI is? So it stands for Splunk IT Service Intelligence. So we'll go to definition of it. So this is the definition. What is ITSI, or we can say introduction to ITSI. Service Insight in IT service intelligence represent the mapping and the monitoring of business and technical service within your organization. Okay, the information derived from service insight help you better detect problems, simplify investigations, triage issues, and accelerate resolutions. So this is a straightforward, simple definition where we can see here it provide a mapping between business and the technical services. So business services, it's a high level which business facing is, and technical where the infrastructure comes in between. So it provide a mapping with your business service to the infrastructure, underlying infrastructure which support that business services. So this is a typical definition of it. Also, it plays around the services. So ITSI is based around the services. So services is nothing but a package, or it's kind of a service where you give a request, and according to that you will get certain response. So this is called a service. So request and response. So we'll go in deep in our future video, so stay tuned with me. So within ITSI, a service is a set of interconnected applications and hosts that are configured to offer a specific service to organization. Service can be internal, it can be internal, or can be external. Like if it's internal, so there is for example, like an organization email system or customer facing. If it's a customer facing, so like an organization website. So website is one of the service which we provide to customer. Now, for example, creating financial report through a web-based application requires a computer, okay, web server, application server, database, middleware, and technical and a network infrastructure. So these applications and hosts are all configured to offer a service to financial reporting. So these all are, so in ITSI we all merge this together and support the service. So how your financial service will look like through underlying. If through that we can find which business service is affecting the infrastructure, or which infrastructure affecting which business service. So like this we can determine. So IT service insight help you map these services depending dependency based on connection between device and application. So this top-down mapping functionally help you immediately see the impact of a problematic object on the rest of the service operations. So this is a typical definition of it. Let's see how it works. Means how can he achieve that? So like I previously mentioned that it's a premium solution, so you need to install ITSI on Splunk. So like I also ITSI uses the platform fundamentals, search, reporting, and everything. So it leverages the Splunk fundamentals. Like we can see through diagram. So this is our inputs. We get the input in Splunk. So this is our typical Splunk, where can be multiple forwarders and everything can be there. Now we install ITSI on top of a Splunk. So generally ITSI will install on searched component, not other components. So it has some additional component. We can go to other components as well. So, but the searched interface, where we create a dashboard, create correlation searches and everything, which sits on the searched. So you need to install, you need to take a license from Splunk support and install it on the searched. Now what it gives, it will give you a service analyzer where you can see the gist or the summary of your services, what all services you have configured. So you can see colorful services, and you can click and drill down. This upper layer is your business services, and it will show top 100 or top 50 KPIs regarding this. So it's a combination of business service and KPIs. So we will go in deep regarding these terms. For now, for you guys, it can be a new KPI business, but KPI and business services we use all around the world. So yeah. So KPI is like, we will go in definition in detail. Next one is this is one of the view in ITSI, we call it as episode view, where bunch of event merge together, similar kind of events merge together and create an episode. So don't worry about it. I will go in detail on each and every topic of it. So next one is again it's a service analyzer, different form of view. We can call it as a tree view, where it follows the top down approach. Okay, and what in on the top you can see business service, and then below you can see any application or any host or anything, something else. You can see it here. So you can define the services as per your need. So next one is glass table. It's a very good functionality of ITSI, where you can see end-to-end flow of your organization or your business. So next one, you can see it gives you a deep dive where from like for particular issue you can see how the other components are interrelated. So these you can see it's a database, then infra, then application, some KPIs or some other get triggered. So you can one by one you can select or remove and can check for that particular time what is happening in your system. Like see here, you can see what is happening in my system at that particular time and which component or which part of it is causing the issue. So here you can see the KPIs and the service as well. So yeah, you can so in short you can get overall picture of your business through that. So that this can be used as a operational purpose or business view. You can call it as a business view as well. So it gives a very good insight of your organization or your business. So it can help you running your operations very smooth. Also you can integrate it through ticketing tool like Remedy, ServiceNow, or you can send an email uh, oh, as and when the issue happen. So like it goes through episode, like where it qualifies for a specific condition. So we create uh, alert for that. So you can send an alert and create dashboard and everything through it. So hi friends, let's start a new topic on ITSI. So this topic covers ITSI features and functionality. So generally, ITSI help you to map the services dependency based on the connection between the devices and application. Okay, so uh, it will provide you a connection between your services and the uh, underlying architecture. So it's generally a top-down approach. So basically, most of the tools provide you a bottom-up approach. So it's a kind of it won't provide you a contextual view with respect to your application. So ITSI provide you top-down approach so that you can check if there is any issue in your services, so you can go and drill down to the bottom, the what is the exact root cause of it. So let's begin with the features and functionality. So ITSI feature and functionality work together to provide a visible and insight into the uh, health of your services. Okay, so let's go one by one. What are the features and functionality? So let's begin. And so as you are aware, there is a two part of any of the organization. First is service manager and second is infra one. So a line of business, you can say first part is line of business and second is app support or operations. So uh, so first and feature of it feature or functionality of it. It is provide a glass table. So glass table is nothing but a kind of a visualization that uh, one can create for the higher management, and they can have look on their services, uh, uh, how well they are performing, or is there any issue with it. So create glass tables to provide a dynamic contextual view of your IT topology or business processes, and monitor them in real time. So data on this these glass table uh, will be a real time. So uh, some KPIs or some queries or dashboard will be running behind dashboards. Reports will be running behind these pictorial representation, and can provide you a real-time data out of it. So it has a drill down functionality also. If you click on here, it will go to either on dashboard, actual dashboard, or can be go to the service view, or can go to reports, or any searches. So you can it is customizable. So whoever work on these glass table can customize it. Okay, so glass tables feature like it's a like a drawing canvas where you can add a visualization in the form of KPIs, services, health score, and upload image and icon and chart. So these all are images. Few images are there, and these are the in the box. You can see these are actual data coming from the KPI, or in short we can say the searches which is running behind that. So these boxes are actual data which is coming from the system. So this is glass table. We can say it's provide a very good or contextual view to your business. So and you can find out a better insight out of uh, out of your data in real time scenario. So now we'll move to next feature of it. So next feature is services. So services, it's a kind of a service is a logical mapping of IT objects that applies to your business goal. So it has a certain business goal. A service is like in layman language, we can say service is kind of functionality which provide a response with respect to any request. So when you give any request to service, so it will definitely will provide some response. So a simple example is when you are ordering a pizza. So it's kind of a request, and you will get the service back the delivery of a pizza. So this is simple. The definition of services is fairly broad. Like there can be a different examples as well. For example, a service can be uh, like an application or a group of application and infrastructure tier, such as web, database, network tier, and a business service such as online store, and they can have multiple tiers. The online store can have a database application or network, these kind of services. It can be a single process such as online instance of an application running on host. So that application also provides some services. So so there are mainly two types of services. One is business service. You can see it over here, and another one is technical service. Business service, which has business means front facing services, and technical, which will be the back end processes. Technical services is mainly a back end process. Okay. So create business and technical services that model those within your environment. Okay. Some services might have dependencies on other services. So there can be in any the environment, there can be multiple dependency of services. So this service can depend on, like, a database service can be dependent on a network. Okay. Or uh, order services can be dependent on database services. So like fetching the order from fetching or searching for the order, it's only mainly dependent on a database service. Okay. Services contains KPIs, performance indicator, which make it possible to monitor service health. So there is one keyword called KPI, key performance indicator. It's a measurable unit upon which we are measuring any unit or any services. So we can perform a root cause analysis. We can do the root cause analysis. We can receive a alert uh, on the services, how service is behaving. So we can set up a service, like alert we can set up and ensure that uh, your IT operations are in compliance with the business level agreement. So all these whatever we are doing, we are doing it for uh, meeting our SLS. So service plays a main role, because we are doing we are calculating SLA for the service. So this is one of the feature of it. The next one is service health score. Service health score is weighted average of a severity value of services, KPIs, and dependency. So as I mentioned earlier, service has some dependencies and some KPIs. So on the basis of dependencies and KPIs, service health score will be calculated. So, and the service health score, uh, it can be for a business service, it can be for a technical service. Okay. So technically, the health score is a KPI attached to every service but it's populated by a single search within ITSI. Okay, so this is one of the things. Insight uses the health score to assign the service a service level and color in the service analyzer and its glass table. So there is ITSI uses, means ITSI has ITSI Insight. So I see ITSI Insight generally uses service health score functionality to show uh, its health as well as the color coding out of it. Okay, so it shows in such a way that, okay. So this service health score is also very critical for ITSI. The next one is KPIs. So key performance indicator. So key performance indicator is uh, in terms of ITSI, it's nothing but a saved searches. So saved searches, what it does is it gets the data from the it's calculates the a certain value from your data and compare with the actual we can compare it with the threshold value. Okay, so so for now you need to consider that it's a KPI searches, it's a save searches that return a value of a IT performance matrix such as CPU load, percentage, memory used, percentage, response time, and so on. Okay, so these can be the KPIs. A KPI is used to monitor the health of the services. So as I mentioned earlier, the KPI is responsible to monitor the health of the services. So if you can see, a business services has a KPI like number of customers. So these are front facing, number of transactions. These are front facing, number of logins. So these are the front facing. So or we can call it as a business service KPIs. Now you can, can go to uh, if you go to technical services, it has CPU utilization percentage, average latency in millisecond, free storage in percentage. So these are the technical service. Uh, so these are the backend, you can say backend, or in technical terms, these KPIs are in technical terms. Okay, you create a KPI within a specific service. So whenever you define a services, so you need to you can create a KPIs. Okay, it defines everything needed to generate search to understand the underlying data, including how to access, aggregate, and qualify with the threshold. Okay, so when you define it, when you define the services, you need to give the KPIs, and you need to define a rule how you need to define first searches, how from where the value should come, KPI value should come, and you need to define the aggregation rule, how it should be calculated and served to the services. Okay, you can use the search result value to monitor service health. check the status of IT component, and troubleshoot trend that might indicate an issue with your IT system. Okay. So for example, we have CPU load percentage is a KPI that measures the CPU load percentage on the server. So this is a simplest example. Then that your KPI is CPU load percentage, and now you're measuring that with respect to your server with the actual data which is there on your indexes. Okay. If your organization has a site up guarantee 99% per month, you will need to monitor the status of KPI to ensure that the CPU performance remain within the acceptable parameter. So this, the 99.9 will be your SLA. So if you want to meet that, what you need to do is you need to monitor your KPI in such a way that it will save your SLA. Okay. So KPI is very crucial for ITSI. So when you plan for, I'll show you how, when we are planning to for uh, planning for service, creating services, creating KPIs, and creating entities. So I will cover that as well. So next feature will be the entities. Entities are like entity in IT infrastructure component that required a management to deliver an IT service. Okay. So each entity has a specific attribute and the relationship to other IT process that uniquely identify it. So uh, the basic example of it is physical virtual cloud resources. So entity can be a physical virtual cloud resources. It can be a network devices, switches, router. It can be a user. It can be a storage system. It can be a volume. It can be a operating system or process. It can be a software application, DB, web, or a business app, application process instance. So and cell tower. It can so those can be the entity. So each entity has a specific attribute as I earlier told. So and relation to other IT processes that uniquely defined. So when you create uh, services, so services you need to assign some entities to the services. So like as I mentioned, the service can be the entity can be anything, physical or virtual. Like suppose there is one application server is there which is hosting on some servers. So you need to while creating services, you need to specify those entity as a serving component for that server. And we we are going to measure the KPI for those entity which is serving to services. So and we need to identify how those services are behaving on the basis of KPIs. So KPIs can be on the host basis, or can be on the entities, or can be on application. So it's a part of design when you are designing uh, your ITS solution. So you need to find out how you want to uh, get the KPIs calculated for your entity or your service or your application service and so on. So this is brief about entity. So entity contains the information ITSI uses to associate services with information found in Splunk's searches, imports and integration. So you can get the entities through any services, or you can import, uh, or you can integrate through third parties, so you can get the entities from there as well, or you can import it manually. You can use this entity information to filter items according to the entity definition. So whenever you are doing, you need to define the entity definition, so that the entity can get in your system. So next one is event analysis, analytics. So event analytics is nothing but is it provide you a dashboard kind of view where you can see your all the notables. So there is one term called notable in ITSI. So notable is like uh, uh, notable that means for notable also we create a searches. So notable, it's a bunch of alerts that should be noticed. So bunch of alert that should be noticed. So say the CPU is going 80%. So there that can be a notable, but do you want to put it in action, or you want to create it in terms of alert? That depend on you. So notable can be actionable or cannot be actionable. So this dashboard will provide you the group of notable events. So group of notable, similar kind of group of notable events called episode. So we will talk about the episode in future videos. So episode notables, everything we will talk in about them in details. So the event analysis will provide an intelligence view that club all the notables together in episode, and from that episode you can do automatic action on that episode, or you can do the analysis whether that event is qualified to raise an alert or no. So it's kind of a view. So next one, so it can have like the as I mentioned earlier, the logs and metrics stays wire DB, social events, APIs. So all the data will be coming from the logs, or there will be a certain sources will be there which is providing you the KPIs and entity details. So there can be a multiple KPIs can be associated to one service. So we can define multiple KPIs so that can produce an alert. Okay. So the next one is adaptive threshold. So before that, we need to understand the threshold. So when you creating services, you create a KPIs and define a threshold. So defining a threshold like my CPU is if it goes to 90%, so raise an alert. So this is kind of a threshold. Now this we are moving towards machine learning. So ITSI provide you adaptive threshold feature where Splunk its own or ITSI its own define the threshold for the service or for the KPI. So it's kind of for this generally we required a machine learning toolkit. So uh, So the adaptive threshold are the type of threshold configured for a KPI that's populate based on the statistical distribution of history KPI data. So it's totally depend on the historical data. So it's calculated on the basis of historical data. They use a machine learning technology to analyze historical data and determine what should be considered normal in IT environment. So it's totally depend on the historical data how it is behaving. So according to that, it will create a threshold for your service or KPI. The adaptive threshold automatically recalculated on a likely basis so that the slow change in the behavior don't trigger a false alert. Okay. So the next feature is anomaly detection. So anomaly detection generates a notable event when the KPI ITSS service intelligent uh, deviate from expected pattern. So it generally create a pattern. So it's a kind of outlier. If it sees any outlier, it will trigger an alert. Outlier is not a right word. You can say it's anomalies like uh, deviating from the baseline. So when it is deviating from the baseline, it will trigger an alert. So for this also, it it runs on few of the algorithms. So for this also you need to install learning toolkit. So these notable events represent detect anomalies of service level trend. So when you are doing this, it will determine the trend and the entity level KPI data. The algorithm learn KPI pattern continuously in the real time and detects when the KPI depart from its own historical behavior. So adaptive threshold and the anomaly detection is totally based on historical data, and it's applies its own algorithm and provide you the output. So in terms of threshold, it will means in the both condition you can trigger an action on the basis of your event. So the next one is deep dive. So deep dive can provide you it generally uses it generally when we use it, the dive when you want to troubleshoot a real-time scenario. So you add here you can add multiple KPIs, okay, and you can find on that particular time how your KPIs are behaving and where the problem is at that particular time. If any trend or anything is up and going down, like suppose there is any problem in login or anything, you can drill down and go to which KPI is behaving abnormal. So deep dive, you can we will have a detailed learning about all these topics. So next one is predictive analysis. Again, predictive analysis also it's totally depend on machine learning. So the last one is it's last but not the least. You can uh, after the event analysis, once you have the events in the event analytics dashboard, uh, from automatic or manual action you can trigger an alert. You can integrate it to remedy. You can integrate it to snow and any other tools you can integrate. So combine this all the functionality is provided in ITSI. So these functions and feature will provide you insight of your IT infrastructure, and accordingly as per the service health score or as per the service color coding or the dashboard which is provided in the glass table. So apart from this, there are multiple things uh, we have in ITSI. So uh, hi friends, this video is about rules engine. So this rule engine is very important uh, part of uh, ITSI. So before I start, there are few things which we should know before start about the rule engine. Uh, First is correlation search, and another one is NEEP, Notable Event Aggregation Policy. So correlation search generally we use in ITSI to find out any notable events are there in system or no. For example, if uh, your memory utilization is high or CPU utilization is high, so you create a notable, and uh, uh,
notable that gives you an kind of alert that you want to act on that alert or no. And NEEP, notable event aggregation policy, is club group all similar kind of events into a single episode. So episode is a kind of a grouping of similar kind of incident, or we can say it correlates all the event together and form a episode. So this is a functionality of NEEP. So NEEP also has actions. If you want to perform any action uh, on episode, so you can do action like sending an email, creating a ticket, pinging a particular host, or running a script, or some other things. So these are the basics about uh, correlation search and notable event. Now let's come to the rules engine. So this is, we can say, it's the heart of uh, ITSI uh, ITSI framework. So let's begin with the overview of rule engine. So the ITSI rule engine is a system for continuously processing notable events to allow for event grouping and deduplication, as well as automatic action execution based on the user defined criteria. Okay, this definition very straightforward. So where the rule engine is a system for continuous processing the notable events. So notable events are, as I mentioned, that correlation search will create a notable event, and rule engine will help to group it together and process it, deduplicate it, and also it helps to automate the action execution, and those will be on the basis of user defined criteria. So user can define any action like sending an email, as I explained earlier, or any other action. The system revolve around a continuously running indexed real-time search that stream all notable events into a custom search command. So there is an index called uh, ITSI tracked alert. Tracked alert, all the notable events go to those tracked alert, and also it gets that tracked alert into as an input for ITSI rule engine, and work upon it and do all kind of actions. So the next part is rules engine search. So as I mentioned, the rules engine is nothing but a real-time search. Real time is continuously run take events from the tracked alert event, as in it's a notable event, and it's where the CPU and memory utilization is high, and it's not a simple event, it's notable event, and those notable event go to ITSI rule engine, as this is mentioned over in the search, and also it perform grouping, create episode, and do the things which is required to grouping together. So this is a typical search for it, and this is a macro. You can see it's a macro. So it's nothing but it has index equal to ITSI tracked alert written over there. So this is about ITSI search. So so the ITSI rule engine search is a component that group notable event into episode based on the filter criteria you define in the aggregation policy, and the search runs with a time range. Early is equal to right, and latest is equal to RT. It includes the index real time is equal to 1 to focus Splunk to stream all newly indexed event directly to the custom search command, uh, that is called custom search command, called that is ITSI rules engine. And finally it has a where clause, ensure the output of a search command doesn't linger in the dispatch directory. Okay, so this is about uh, rule engine search. So this is a real-time search. It continuously runs in background real time, so it always search for the notable events. So next one is about how the rule engine works. uh, a notable event policy is a fundamental unit of a rule engine. Aggregation policy are the data uh, structure the rule engine uses to group notable event into episode. It also contains for action rule engine that automates episode action. Okay, such as sending an email and everything. I'm repeating again and again. Uh, so let's just move how the rule engine works. So the rule engine functions begin with the correlation search. Now we will discuss it through a diagram. So this begins with the correlation search. Correlation search generate a notable event in ITSI, as I earlier mentioned that it generates notable event in ITSI which are stored in ITSI tracked alert. So this is the index. The notable events comes over here. The rule engine save search accepts the notable event into ITSI rule engine custom command. So ITSI rule is I earlier mentioned that accepts the notable events into ITSI rule engine command through save search. The search command generate the internal structure required to aggregating event into episode and execute events. So that command, as I earlier mentioned, this command structure the data so that the event can be grouped together and perform a particular action over it. So this dispatch or any other actions are there. So episodes are stored. Episodes are stored via HEC. So it called HTTP event collector HEC to grouped alert index. So here this is called a grouped alert index. So the episodes will be stored over here. So index for this is ITSI underscore grouped underscore alert. So this is the index for grouped alert. If you want to search for it for a specific grouped events or for the episode, so you can find it in ITSI grouped ITSI underscore grouped underscore alerts. Okay. So for notable event, it is called ITSI. The index called ITSI underscore tracked underscore alert. For group, it's ITSI underscore group underscore alerts. Okay. So after this means through HEC, the grouped event goes to index, grouped index. All the episode metadata is stored via REST events to the KV store. So the KV store name is ITSI underscore notable underscore grouped underscore system. So this is with respect to system, and for the user it goes to ITSI underscore notable underscore group underscore user KV store collection. So these are the name of collection. I will give the details of all the things, index and the KV store collection used in IT by the rule engine. I'll put it in comments. So here we have events grouped together into the index, and we have a metadata or user related data into the KV store. The rule engine search periodically polls the configuration database updates. If a policy indicates some action should be executed, the rule engine dispatch a REST request to the event management interface to execute the action. Okay, so it searches also, the rule engine searches whether there is any action defined or no. So if any action defined, it dispatch those action to event management through event management REST API, and then action will get executed. So The action can be anything. It can be ticketing or any other things. So as you can see that the blue line is typical ITSI functionality, and the other things are Splunk Enterprise. So this is like HEC, index, episode stored, KV store, and searches, index, save search is part of enterprise, but enterprise Splunk. But these are uh, combinedly the functions for uh, the ITSI rule engine. So, for the basic understanding of ITSI rule engine and how it works, I have defined it in this video. In upcoming video, I will try to uh, talk about the properties of rule engine, or the other advanced configuration for the rule engine. So thanks for watching the video, and have a good day.